Okay, welcome back. If you've tuned into me before, you'll know the routine for these. If not, if you're a new person, I'd really appreciate if you could subscribe or like my video. That would be really much appreciated. In case you're new to the channel, what I do is lots of little videos that help people with mathematics, mostly people who are revising for the GCSE summer exams. This series particularly is a new series, and you can see from the title at the top there, this is about think and do questions. I'm going to do a different bunch of questions over the next few days. This particular set is a set based on quadratics. So these are like some of the hardest questions that I could pick out from the high tier examination on quadratics, and I'm intending to go through and just take you through some of these questions that just make you think a bit more than the normal questions, just give you a bit more thinking to do. Right, without very much delay then, let's get on and have a look at this particular question. This question number one is a sort of selection of circles really. So we've got this big circle round here that has a radius of 2n plus 6 and a small circle of n plus 1. You consider talking about a region R which is shaded in the diagram here. So that region R, and they're talking about different circles, and then they're basically saying, look, the area R, so this area here, is greater than the area of the radius, or circle of radius n plus 13. N is an integer, it's quite important, and it's asking for the least possible value of n. So there's quite a lot of stuff in this particular question. But fundamentally, it's all to do with areas of circles. So we do know the area of a circle, and so we can probably then use that information to help us with this a little bit. So we know the area of the big circle, for example, is going to be pi times this big radius here, 2n plus 6 squared. And the area of the small circle is going to be pi and then the little radius squared. And of course what I'm doing here is I'm constructing an idea for the region R. So I'm doing the area of the big circle times the area of the small circle, and then what would be left is this grey shaded area. And it tells you in the question that this particular area is more than the circle of radius n plus 13. So I'm going to write an inequality here, and I'm going to construct that particular circle, n plus 13 all squared, because again that's the circular radius that we would have. So how do we simplify this? Well, you've got pi's everywhere, so we can certainly divide through by pi, and then we've got a bunch of quadratics that we need to, brackets that we need to multiply out, which will create some quadratics for us. So we've got 2n plus 6 all squared. Now if you're not very good at multiplying out brackets, you can certainly try and get more used to writing brackets as pairs like this, and then multiplying them out. So the first two terms multiplied, and then the outside terms, and then the inside terms, and then the last two terms, and you'll get 36 here, and then 12n, 12n is 24n, so it's 4n squared plus 24n plus 36. And I would encourage you to get used to multiplying out brackets because it's a skill that you need a lot. So this will go down here. I'll just use a bit more space down here. So this is the 24n plus 36 that we had up here. And then this one here, so I'm going to use a pair of brackets for this because I've got to be careful with my minus signs. So I'm going to have n squared and then minus 2n, then plus 1, because minus 1 times minus 1 makes plus 1. And then lastly over here, I'll leave this as a bracket for now because I haven't really got enough space to multiply it out. On this side then, we're gonna do 4n squared, take away the n squared, that's 3n squared, 24n minus, so two minuses, 2n, so that's two minuses make a plus, so it's 24n plus 2n, that makes 26n, and then plus 36 minus 1, that makes 35. Now we'll multiply up these brackets, so that's n squared plus 26n plus 169. 26n on both sides is quite useful because that's fortuitous, that can cancel each other out, leaving you with 3n squared plus 35 being more than n squared plus 169. Now the n squareds, I can bring them all together, so 3n squared take away the n squared gives you 2n squared. 35, I'll bring that over the other side, so 169 take away 35 is 134. and then dividing everything by 2 will give me 67. And then because we've been told earlier this is an integer, so this is n squared being more than 67. So what number squares to make more than 67 where n is an integer? Well, it's only going to be 9, because 8 squared is 64, that's not going to be enough. So 9 makes 81, so it's going to be, n is going to be more than or equal to 9. That is the integer that obeys this particular question, and that will get you the very useful 5 marks. A lot of marks for that particular question. Lots of thinking in there as well. Fundamentally, it's all about areas, and you've got to be familiar with how that works. For question 2, again, a very similar sort of concept. Can you prescribe and use area formulae correctly? This particular question is on a trapezium. So it's got a trapezium here. We've got the parallel sides, x plus 5 and x minus 4. We're being told in the question that the area of the trapezium is 351, and then we're having to show something. So show. So using this information here and this information here, we're being asked about area of a trapezium. We know the area of a trapezium is half the sum of the parallel sides. So the parallel sides are x plus 5 and then x minus 4. It's half of the sum of those. So I'm going to halve those. And then times by the perpendicular distance between them, so 2x here. And we're being told in the question that's 351. Now, what we're then going to do is we're going to do a bit of jiggery-pokery to add these all up. So x plus x is 2x. 5 minus 4 is positive 1. And then that leaves you with 351 here. The 2's can cancel out. So I'm left with 2x plus 1 times by this x. So x outside the brackets, and that's equal to 351 here. Now, at this point, we're going to multiply this out. So 2x squared plus x, and then take away the 351 equals to 0, and we've shown what the formula wanted us to show, or the question wanted us to show. So I can say as shown there, just to show that we have got what they were asking for. Now, for working out the value of x, this is not so easy. You're looking at these numbers and thinking they're very big, so this is probably going to be a question that's to do with using the formula. So indeed, I'm going to go ahead and use the formula here. So you should know what that formula is. You do have to learn it. So just in case you don't know, this is the quadratic equation formula, and you do need to learn it. And then what I'm going to do here is I'm going to substitute the values in. So minus b, first of all, is minus 1. B squared will be 1 again. And we've got minus 4 lots of 2. And then minus 351. That sign's quite important. And then divided by 2 lots of 2, which is 4. And then what that will do is it produces for me, you have to multiply these things together. So I think this was in the calculator paper, so you can probably go ahead and use a calculator to type that out. I'm just tapping away here on my calculator to get what this is. You eventually will get 2809 when you work that out. Square root of 2809, you're going to get 53. So we're going to have this as a range of things. So it's either minus 1 plus 53 divided by 4, or minus 1 minus 53 divided by 4. Well, the second of those values is not worth worrying about, because minus 1 minus 53 divided by 4 will be a negative number. And we know that this is for a trapezium. So going back to trapezium, x had to be positive. So we're going to have to ignore the negative one, just work with the positive one. So minus 1 plus 53 is 52, and 52 divided by 4 is 13. So the answer is 13. Okay, so just making sure that I've got that now down there. And again, 5 marks for this question. So these thinking do questions are just a little bit more valuable to you. You do need to make sure that you've got your head straight around what these questions involve. Question 3 is a probability question, which then turns into a quadratic question. So again, still in the topic of quadratics, and but this one to do with probability. So it's talking about socks in a drawer, He's taking 2 socks from the drawer and putting them on, I'm assuming. And you're looking at probabilities. So it's a tree diagram question, really. And sorting your way through that and synthesizing your way through that is important. So understanding it's a tree diagram question is partly part of the problem. So you do need to recognize when you do get tree diagram questions. My only suggestions for that would be just to look at when you've got a limited number of possibilities like this, so black or white. If you're asked for repeated steps, so in this case you're taking 2 in a row, so those sorts of things, those sorts of characteristics, what you look for a tree diagram question. Now you've got 2 possibilities, black or white. So I'm going to sketch out a small tree diagram here at the top here, and I'm sort of putting in the different possibilities. Now I've deliberately placed them in that order. You can do B and W again, but I've deliberately put them like this because I haven't got enough room really to sketch everything down, and we're only asked for 1 white sock and 1 black sock, so I'm only going to be interested in this branch here, so the white followed by the black, and or this branch here, so black followed by white. So it's black and white or white and black. Okay, so those are the 2 branches I'm interested in. I need to write down all the possibilities. So I've got black socks here, I've got Y black socks here. I hope you can see this, I'm going to make it a bit closer for you. And then 5 plus Y socks in the drawer. And then 5 white socks, of course. And because I've lost a sock, it will be Y minus 1, which effectively will be 4 plus Y here. And then the same thing happens down here. So we've got 5 and 5 plus Y. So 5 white socks, 5 plus Y. And then if you lose a sock, you're going to have then Y and then 4 plus Y underneath. So it's the same probabilities, just in a slightly different order. So you can see that, same thing. We're being told that the probability that Josh takes 1 white sock and 1 black sock is 6/11. So we know it's this and this, or this and this. So try and write that down into mathematical speak. It's these 2 things. This is the mathematical conversion of what we've just been talking about. So there we go. So it's black and white, or white and black. So all the way through, we are absolutely trying to write these things down carefully. Now, for this one here, we've got 5Y, and then we will have on the underneath 2 pairs of brackets multiplied out, 5 plus Y and 4 plus Y. So over here, I'm just going to multiply what those are when you multiply them out. So we have 20 plus 9Y plus Y squared. So 20 plus 9Y plus Y squared. And then this is exactly the same thing. So write that down again. We're told in the question that this is 6/11. We have 10Y on the top. And then I have 6/11, and then I'm going to take out that 20 plus 9Y plus Y squared over this side. Hope you can see this okay. And then multiply this by 11, so 110Y. And then I'm going to multiply out these brackets, 120, 9 sixes are 54, and then 6Y squared. And now I'm going to divide everything by 2 because I can see everything divides by 2 carefully. I'm also going to bring the 110Y over here to get everything together. So it would be, in this case, 6Y squared, 54Y take away 110Y will be minus 56, right? And then 120 equals to 0. So I've just rewritten it slightly, taken some things together, and now you just have to halve everything. So 3Y squared minus 28Y plus 60 equals 0, and you will see this is the form of the equation that the question was asking for. 4 marks. Probability that Josh takes 2 black socks. Well, in order to work that out, we need to know what Y is. So they haven't got you to do this for nothing. You're going to need to work out what Y is. So this is a quadratic that you just need to solve. Now, this is a reasonably good quadratic to solve because we can see that 360s are 180 here. So I can see this is going to be factorisable. So we're looking for factor pairs of 180 that make minus 28 in the middle. And that will be minus 18 and minus 10. So those two multiply to make 180, but also they subtract to make 28. Now, then I'm going to write down 3y squared at the beginning of this, minus 18y, minus 10y. So where's this come from? It's come from over here. And then the plus 60 from up there. And then we're going to have, do some taking out brackets. So y minus 6 here. And then finally here, it's going to be y minus 6 as well. And this will give me 3y minus 10, and then y minus 6 again. And then again, in a similar way to the previous question, y has to be a positive number. So this one's going to be something we have to eliminate because that's going to give you 10 over 3, which is a positive number, but it's an integer. It's not an integer. We need an integer because it's black socks we're referring to, or number of socks we're referring to. Y is 6 here. So we can see that y is 6. That's the number of black socks we have. So 2 black socks will be 6 over 11, and then we're going to have, after you've lost a black sock, 5 over 10. So those two things multiplied together, and that's going to make 30 out of 110, which is 3 over 11. Again, lots of marks for these questions once you've thought them through. So lots of marks for these questions, really worth you while thinking through these things and just understanding what's going on. So well worth those 7 marks that you're going to get. This one here. Right, so this one here, again, this is solving by factorising. Again, so this probably would have been in the non-calculus paper, this particular question. It's a bit of a favourite, this one, for asking in exam conditions how to solve this. So it's one that you will probably see again. So just be aware that there's a standard set of formats for these, but in case you're not sure about what to do, you would do 8 times 27. Now 8 times 27 is going to be 216, I think. Yep, that's right, isn't it? Yep, 216. So you're looking for factor pairs of 216 that then add up to make minus 30. So it's, if you think about it, it's 6 and 36 are the pair that you would want. And because it's minus 216, we're going to have 6 and minus 36. So again, I'm very well used to doing this particular question, so don't be taken aback by how quickly I've done it. It's just I've seen this question so many times before, so I know what to expect with this. And I would say that once you've done this and seen it once, just keep practicing it, because this one does come up from time to time. You will see it a lot, so very well experienced to seeing this one. So as with the previous question, we've got 8x squared. We're going to rewrite these in order. So I'm going to have minus 36x, and then plus 6x, and then minus 27 equals 0. Where did this come from? This came from over there, didn't it? So that's what we're doing here. And then we've got these two we're going to factorise. So we're going to take out, in this case, 4x. And we would have 2x minus 9. And then these two we're going to take out, it would be 3. So 2x minus 9 equals 0. And then so you're going to get 4x plus 3, and then 2x minus 9 equals to 0. And again, these two solutions then will give you minus 3/4 or 9 over 2. Okay, so those are the two solutions that you're being asked for. It's a lot of work to do for 3 marks without a calculator, it really is. Question 5, this particular question is really straightforward. It's just standard factorisation, looking for factor pairs. Because it's got a coefficient of x squared as 1, you're looking for factor pairs of 35 that add to make 2. So that would be 7 and 5, or in this case 7 and minus 5. So it's going to be x plus 7, x minus 5, and that works. And so you're left with x is minus 7 or positive 5. So very straightforward and easy. This one here, much more difficult. So you need to think about what you're doing here. So we're going to look at this algebraic fraction situation first. Again, algebraic fractions questions always give rise to quadratics, so you should be used to seeing these. We're going to multiply out what this fraction looks like. So we're going to have 2 lots of 2x plus 3, and then x lots of x plus 1. So we're going to cross multiply on that left hand side first of all, and then underneath we're going to multiply those two denominators together. Okay, that's how you start with algebraic fraction questions always. Because I've got a 1 over here, the easiest thing for me to do is probably to multiply out by this denominator and sort of move it over to that side. So I'm probably going to do that. So I'll multiply these brackets first. So 4x plus 6, and then x squared plus x. And then over here, I'm going to have this pair of brackets that I called out from earlier. So that's just multiplying out. And then I'm going to multiply out these. So first 2 terms would be 2x squared. Inside terms would be 2x. Outside terms would be 3x. Last 2 terms would be 3. And this would give you 2x squared plus 5x plus 3. And then here on this side, we're going to have x squared plus 5x plus 6. So that's what's going to happen here. Then going to take everything over to the same side. So 2x squared minus x squared is just an x squared. 5x, take away 5x, so that's going to cancel itself out. And then 3 minus 6 is minus 3 equals to 0. And again, now you can see how this is going to be solved, because x squared is 3, which means that x is plus or minus the square root of 3. Be careful that you know it's a plus or minus square root of 3. It's not just the positive root, because of course quadratics can have 2 solutions. So 4 marks for me. Final straight now, so 2 more pages to go. This one here is an inequality problem, but again gives rise to quadratics quite quickly. Multiplying out on the right hand side, we're going to have 3x plus 18. Taking it all over to the same side, we're going to have x squared minus 3x minus 18, sorry, not equals to 0, but more than 0. Because it's an inequality question, we do need to sketch this, so I'm going to sketch this out. This is quadratic that we can solve and factorise, so we're looking for factor pairs of 18 that make minus 3. So that would be minus 6 and plus 3. So that's the pair that you're looking for. This gives rise to the root 6. This gives rise to the root minus 3. We're going to sketch the quadratic, which looks a little bit like this. It's a happy graph because it's got a coefficient of x squared as positive. And then where is it more than 0? It's more than 0 everywhere above 6 or everywhere below minus 3. And that would give you the 4 marks. This question 7, similar to one from earlier really. Limited number of possibilities, and then looking for probability, it's a tree diagram question. Let's just read through and just see why. So it's talking about n sweets in a bag and 6 of the sweets being orange, the rest of the sweets being yellow. She takes at random a sweet, she eats a sweet, so it's without replacement, and then so on. So she's limited number of possibilities, limited probability, looking at a repeated cycle, so taking a sweet, taking a sweet. This is a tree diagram question, so we're going to sketch a tree diagram just like we did earlier. So orange and yellow, the 2 possibilities. Again, I'm going to be just put those possibilities down there. We're then going to suss out what's going on. So 6 of the sweets are orange. And how many sweets does she have in the bag? She says it has n sweets, so 6 out of n. How many sweets would be yellow then? It would be 6 minus n over n. Or sorry, the other way around actually, isn't it? It's n minus 6 over n. And then over here we'd have, because we've taken a sweet out, so it's 5, we've eaten an orange, so it's n minus 1. And then here we would have n minus 6 over n minus 1. And then here, orange-wise, we've got 6 over n minus 1. And then here we've got the yellows, so n minus 7 over n minus 1. Took some thinking. Really, none of the other possibilities worry us apart from the one that says 2 oranges. So this one here is the one we want. So it's 6 over n followed by 5 over n minus 1 that we need. So it's this. because it's an and problem, we're going to multiply them. That's 30 over n squared minus n. We're being told in the question that this is the third. So we're going to multiply out on the right hand side. I can take the 3 over, make that 90. And you can see really quickly we're going to have a variation on the what the question asks for. And that's what the question's asking us for here. So 3 marks. It's then asking you to solve them. So we're looking for factors of 90 that make minus 1. So 10 and minus 1, or minus 10 and 9, right? Yeah. So these would make this would work. Again, because it's a number of suites, it can't be negative. So we disqualify the value that gives us minus 9. It can only be 10 suites. So that's why that particular answer is the only answer we take into account. The last page is a bunch of questions on completing the square. And completing the square is an area that will definitely come up over at least 2 of the papers usually, but certainly at least 1. So you need to be careful about how you're doing completing the square. Always looking at the middle coefficient, always looking at the first coefficient. If the first coefficient is 1, which it is here, it's a straightforward question. So you just need to halve that middle coefficient. So that would be x minus 4 in this case, and imagine squaring it. Now, if you square that last term, you're going to get positive 16. So you take that 16 away to cancel out that effect. You've got the plus 6 from earlier, which hasn't gone anywhere. You still need to leave that in there. And then so you're left with x minus 4 squared, and then this would make minus 10. So in this form, it's this. Minus 4 squared minus 10. Be careful about your signs here, because it's minus p and we've got 4. It's a 4, right? Not a minus 4. Lots of people write down minus 4. And then q is minus 10, because that is the last value here. So be careful about your signs on this. Lots of people make some silly mistakes. So be careful about how you're writing these things down. With regards to minimum points, this constructs a minimum point for you. Minimum point is always going to be the inverse of this. So 4 is going to be the x coordinate, and then minus 10 would be the minimum point. So if you were to sketch that graph, that's roughly where the minimum point would occur. Okay, that is the last question from this particular set of questions. That was Think and Do for Quadratics. I hope you learned something there. Do rewind it back and have a look through and try some of these questions for yourself. They're easily findable on the net. I'll keep putting links up for future questions shortly, so do tune back and have a look over the next few days, because you'll see a few of these arriving. This will all be put into a playlist for you as well, and as I said earlier, please do leave a like or subscribe to my channel, which would help me out a ton. I hope you have a really good rest of the day. Goodbye for now. Bye bye.